Hello everyone, this is Alan C98, and this is the third part of my series on the DryOT project. In this part, we're going to wrap up the project by programming the Raspberry Pi and testing it out to make sure it does what we want it to do. Just a short recap, Project DryOT is an IoT or Internet of Things laundry room monitor. I'm using the Raspberry Pi Zero W with wireless, the Pimoroni EnviroPHAT, and a custom 3D printed mount with suction cups to mount this whole gadget to my dryer. You can see here it's mounted to the dryer, and the whole purpose is to pick up vibrations when the dryer is running and tell how long the dryer's been running. So you can see here on the little MQTT Dash Android app, this is the project in action, where it can tell the dryer runtime, it can tell that the dryer is still on, and it can monitor the light level in the laundry room and tell whether or not I left a light on. It also saves the previous runtime of the dryer, and it can also monitor the temperature. So in short, it's basically allows you to monitor what's going on in the laundry room and watch the dryer from the convenience of your phone anywhere in the house. And as you'll see later, we can use Adafruit IO to even look at this data outside of the house. Okay, so once again, just a short recap, the project goals. Monitor the motion sensor to tell if the dryer is running or not, monitor the temperature in the laundry room, and monitor the light level or tell if someone left the lights on in the laundry room. Future goals could include adding a Raspberry Pi camera so we can actually watch the little LED display on the dryer to see how long the dryer is supposed to be on, although we do detect how long the dryer has been on. And another future project I'd like to do is add a little Arduino or CircuitPython based monitor with a little LCD screen in our kitchen so we can basically tell what's going on with the dryer just by glancing at the kitchen. You don't have to pick up your phone or bring up a web browser. Alright, so let's get started on part 3, software programming. An overview of what we're going to do. First, we're just going to go over the program organization and the data flow. Talk a little bit about the program design. We have 2 Python programs here. One is called DryOT sensor loop.py, and that's the main program that collects the data from the EnviroPHAT, processes all the data, and then publishes our topics to MQTT, all of our dryer data. The second program is completely optional. It's called DryOT pub to adafruitio.ini. It's a Python program that will subscribe to our DryOT MQTT topics, and it'll republish them to Adafruit IO MQTT feeds. So if you want to republish the data to adafruit.io so you can look at the data outside of your home, then you can use a script. But if you're not interested in using Adafruit IO, or you just want to keep everything in your local network, then you can ignore this program and not use it. And finally, we'll go over installing the programs on the Pi and getting them running. And again, the code is available here on my Github account, and I'll have that in the program description so you can click on it directly if you would like. And I'm also including these slides so you can get them as a reference. Okay, a little bit about the data flow. So what we're doing in the first program, the DryOT sensor loop.py, is we're reading sensor data from the EnviroPHAT, processing that data to produce our MQTT topics, such as whether the dryer is on or off, whether the lights are on or off, the temperature, and the time that the dryer's been on. We publish this data to the MQTT server. So really, if you don't want to use Adafruit IO, that's all you really need. You can use other MQTT client programs, such as the MQTT Dash that I use on my Android phone, or you can use Windows MQTT clients or Mac MQTT clients, and you can read this data. But if you want, you can also publish this data to Adafruit IO. The program DryOT pub to adafruit.io, that will actually subscribe to my DryOT MQTT topics, and it'll republish that data at a much slower rate to adafruit.io. It's important that we don't want to overload adafruit.io with the amount of data we're sending, especially if you're just using a free account like I am. So let's talk a little bit more about the first program, DryOT sensor loop. Its purpose is, as I've said before, is to collect data from the EnviroPHAT sensors, processes that data to determine is the dryer on, how long has it been on, is the light on, and also it collects the temperature. And it publishes all that data to the MQTT server. A couple of notes here. There might be a better way of counting dryer runtime. Basically, I just have a loop where each iteration of the loop is 1 second. And it'll first try to determine if the dryer is running by detecting motion. If it is running, it'll try to add that to the dryer runtime. It is pretty accurate. I had to spend a lot of time tweaking the program and figuring out how to make it accurately count every second, but it seems to be working pretty well now. And I have some parameters that you can adjust depending on how smooth or bumpy or shaky your dryer is when it's running. And I'll go over those in a little while. Also, this program could have been modularized a little bit by breaking it apart so that you can have the sensor data collection in one module that would just publish the raw data to MQTT. And in a second module, you could process the raw data and publish the results back to MQTT. But since it wasn't a very big project, I just decided to keep it simple. Okay, a little bit more about the design of this program. So what do we collect from the EnviroPHAT sensors? We detect motion, or collect the motion data, namely just the z-axis. We collect temperature, which is pretty straightforward. And we collect the light level. And then there's a number of parameters. I have a DryOT.ini file for all the parameters that you may need to adjust if you want to try to adapt this to your dryer. First of all, there's a parameter called onThreshold. OnThreshold is the number of seconds of detected dryer motion before we consider the dryer on. When I first started making this program, I found that if I just started counting time the dryer was on when it first detected any motion, I would get all kinds of false alarms, like if I just bumped the dryer or opened the door or closed the door. So essentially, this is almost like a little state machine. The dryer has to detect, or the DryOT has to detect motion for a number of seconds before the program considers the dryer on. And that way it kind of filters out any bumps or anything. And the same thing for turning the dryer off. You know, the dryer is running for at least 20 or 30 minutes, up to an hour usually. So if the dryer is just smooth for a couple of seconds, we don't want the program to think all of a sudden that it was turned off. So the off threshold is kind of another way of filtering out when the dryer may be just smooth for a couple of seconds. In my case, it has to be smooth for like at least 5 seconds, maybe 10 seconds before I consider it off. And that works pretty well. And then another parameter here is called motion threshold. That's the sensitivity of the accelerometer data used to detect dryer motion in any given second. So if your dryer is really smooth, you might have to make that number very small. My dryer moves around a lot, so the number isn't that small, so you can adjust that depending on how much your dryer vibrates when it's running. The next parameter here is light threshold. And that's the light level where you would consider the laundry room light on or off. And so you can set that accordingly. If you have a darker or lighter light in your laundry room, you can always adjust it and it'll determine what you think is on or off. And then the last one here is publish rate. How often do we publish these MQTT topics? Because the dryer is on for up to an hour, we don't really need to publish data multiple times every second. So I think the default I set here was every 5 seconds, and that's good enough. We could really even make it a minute if we want to. Okay, so that's it for the parameters. Now let's talk about the MQTT topics that are published by this program. So first of all of our MQTT topics start with DryOT. That's so we can kind of distinguish them from other topics we may be publishing on our MQTT server or broker. So the first thing we have is DryOT, dryer state. And that's simple text, and it's either going to be on or off. Obvious. Then we have light state, which is also on or off. Then, if you want to kind of track the light level or lux level, we have DryOT/light level, and that's an integer value. The next topic we have is DryOT dryer runtime, and that's text representing hours, minutes, and seconds that the dryer is currently running when it's on. Now, of course, as soon as it transitions to off, this will be reset to 0. So we want to save the last time the dryer was on so that we don't lose that data in case we're interested in knowing how long the dryer was running. And this topic is previous dryer runtime. So that'll be the same hours, minutes, and seconds format. Then, of course, we have DryOT temperature, which is our temperature in Celsius. So those are all the topics that our program is publishing to our MQTT broker. Okay, so that's essentially what it does. So it collects the data, then it processes the data using the different parameters that we have to help adjust the way things work, and then publishes that data to this collection of MQTT topics. So now let's talk for a minute about the other program we have, DryOT pub to Adafruit IO.py. So again, this is an optional program that if you wish to publish your data to an Adafruit IO account to the MQTT feeds, you can use this program. If you're not interested in using Adafruit IO, or you have another service, you can actually modify this program to publish the topics to another service. Essentially, the purpose of this program is to subscribe to the MQTT topics that we've just went over from the DryOT sensor loop program. Then it republishes that data to MQTT feeds on adafruit.io. And one of the main features of this program is it allows for a slower publish rate. I mentioned that I'm publishing MQTT data from the DryOT project every 5 seconds, but I don't really want to publish it at 5 seconds to my Adafruit IO account. Adafruit.io free accounts allow you to publish 30 data points per minute. The paid accounts allow you to publish 60 data points per minute. So we really don't want to overwhelm the Adafruit.io account, so we have a parameter that lets us slow down the rate of publishing. So, and of course, obviously, you need to have an Adafruit IO account to use this. You can get a free one. And you also need to create the Adafruit.io feeds and dashboard to display the data. Eventually, it'd be nice to have some sort of generic file or parameter-driven approach to subscribing to local MQTT data and then republishing it to adafruit.io. But for now, this script is kind of specific to the project. Okay, a little bit more about what the program does. One of the first things it does is it reads parameters from adafruitio.ini, the initialization file. And in that file, 2 key things here, your Adafruit IO key and your Adafruit IO username. So those are very specific to the account that you create, and you'll have to have those set in this initialization file if you want to use it. So you set this to match your Adafruit.io account name and key. And remember, if you put this online, like if you republish my GitHub repository, make sure you don't put your Adafruit.io account details in here. That should be your secret. You don't want somebody accessing your account. Okay, another parameter in the initialization file is the MQTT broker address. You can just set this to the address of the MQTT broker that you're subscribing to data from. Since I'm running everything on the Pi, including the MQTT broker, I just leave it at 127.0.0.1. If you're running an MQTT broker on a different machine on your local network, or you're using some sort of public broker, then you'll need to change that address. Finally, the last parameter is publish max. So this parameter means that every one of publish max messages are published to adafruit.io. For example, if you have it set to 10, then 1 of every 10 messages will be sent to adafruit.io. And there's different counters for each topic. So the whole idea here is you want to limit the amount of data you're sending to adafruit.io. In my case, I set it to 12, which means all of my DryOT data gets published once a minute, which is fine. Now next, let's talk about the Adafruit MQTT feeds that we're sending. So they're very similar to the MQTT feeds that I'm publishing to the broker on the Pi itself for my local network, but there are just a couple of syntax differences. So first, I'm grouping these feeds in a group called DryOT. So the first one is DryOT dryer state. Note the syntax is slightly different because Adafruit doesn't allow underscores in these feed names. And this time, instead of sending the characters off or on, I'm just sending a 0 to mean off and a 1 to mean on. And that's more helpful for the Adafruit.io dashboards, so you can actually have, a red icon for off and a green icon for on. It's easier to interpret the data with the 1 and a 0. Then I'm also sending the dryer state, the light level, dryer runtime, previous dryer runtime, and the temperature. So it's pretty much the same data, just republishing it to Adafruit. Okay, now that we've talked a little bit about the design of the 2 programs, let's get them installed on the Pi and get them working. So here's an overview of what we're going to do. First, we need to log in, or SSH, to the Pi. You need to know your network address for this part. If you're working with a Mac, or you have another system where you have the zero configuration networking service installed, you can probably just SSH to pi@dryot.local. But in my case, I'm using a Windows machine, so I need to know the static IP address. So I know the IP address of my DryOT project on my wireless network. The next thing we'll need to do is clone the Git repository, and this is the address of the Git repository that has all the code in it. Third thing we'll need to do is customize the initialization files. It probably will take a little bit of tweaking to get it to work with your dryer, and you need to set the light level in your laundry room if you want to monitor the light. Then finally, you need to edit the adafruit.io or adafruitio.ini file. And the most important thing to set in here is your username and Adafruit IO key. Of course, in the repository, mine aren't in there, and so I'll need to add mine back in as well. And then finally, if we want to start the programs automatically when we start up the Pi, which of course we do, in case it ever restarts or something, we need to edit the Pi's etc rc.local script to start these automatically. Then we reboot the Pi, and if things are working the way they should, everything should come up and this project should be ready to work. So let's get started on installing all of that stuff. I'm going to bring up my Smart TTY program from Windows and do a quick SSH connection. I'm going to log into Pi at, and of course I know my IP address for my Pi, so 192.168.0.130, and my password that I set when we did the setup. And it's going to ask me what kind of connection I want, and I want a regular terminal. Okay, so I want the regular terminal here. Adjust it a little bit to make it fit the screen better. So now we're on the Pi. So now the first thing we need to do is clone the Git repository. So we type in git clone https://github.com lnc98 dryot.git. When we hit return, it'll clone everything into the DryOT directory. So it's there. So now if we look, we have the DryOT directory. Now some of these things we don't need, like this directory has the 3D printed mount. If you're going to print that out, you probably want that on your PC instead. And docs, which is a copy of the slides that I'm using, I included a copy in here because it has all the important things like the MQTT topics and all that stuff, if you want to have a reference of it. But the real code is in Pi code. And again, you shouldn't need to mess with these Python programs because all the parameters that you should need is in here. However, everybody's situation is going to be a little bit different, and I can't guarantee it'll work on everybody's dryer, so you might have to get in here and mess with this, but hopefully you won't. First, let's just look at the DryOT.ini file. And I'm not going to have to change any for my dryer because I've already done all the adjustments and tweaking. This actually took a little bit of time to get right on mine, and hopefully the parameters that I've created here will be helpful for you. Look at DryOT.ini. And you can see here we have on threshold, the number of seconds of detected motion before the dryer is considered on. For me, it's 20, because sometimes when you open the door or you're loading the dryer or emptying the dryer, it would fool my program and think that it started running again. And of course, I don't want that. I want it to be as accurate as possible. So I gave it 20 seconds before it determines that it's on. And you could really set it for something like a minute or two, because you really always run the dryer for at least 15 or 20 minutes. So 20 seconds is more than enough. The off threshold, I set mine to 3 because sometimes my dryer would get pretty smooth just when it's tumbling. And I found that it could fool the program and make it think it's off when it's really still in the middle of the cycle. So this could actually be higher as well. and it could be somewhere like 10 or 15 seconds, and it wouldn't really hurt anything, because again, we're dealing with minutes here. This one's going to be a little trickier, and this depends on how much your dryer vibrates or how smooth it is. For me, this threshold of 0.005 is fine because it can detect the motion when the dryer is running using the EnviroPHAT. So if your dryer is a lot smoother, you might need to add a 0 in here. Like start with making this 0.001, and if you have to, make it 0.0001 or something. That's something you can play around with. And then, of course, the light threshold is pretty easy. You can just look at the light level on the MQTT topic and find out what the light level is when the light is on in your laundry room and when the light is off. And you can just set it accordingly. For me, when my light is off, the light level's still at 18, so I just set it to 50, and that's a good threshold. And then the last one here, one of the last ones, is the publish rate. The publish rate is how often I publish the data. So 5 here means I'm publishing the data to my local MQTT broker once every 5 seconds. The other section down here, MQTT broker address, is 127.0.0.1. In the part 2 video, we did all the setup on the Raspberry Pi that we needed, including installing the Mosquito MQTT broker, and we're running it right on the Pi, so the broker address is localhost or 127.0.0.1, and that's all you should need. There's a couple of less commonly changed options, but I put them in here anyway. The number of samples per second. I'm taking 4 samples from the motion sensor from the z-axis, 4 per second, and the delay is 0.15 seconds between the samples. And then I also have a little debug print. If you set this to 1, you could actually get a lot of debug information if you ran the DryOT sensor loop program, because I had to use that when I was debugging the program. So anyway, that's all the parameters, and I don't need to change any of these because I've already tuned it to my dryer. Hopefully all you'll have to do is mess with on threshold, off threshold, and motion threshold. And of course, if you want to monitor the light level, light threshold. Okay, let's take a look at the adafruit.io initialization file. Okay, this just has a few settings. The 2 most important settings, of course, are Adafruit IO key and Adafruit IO username. You're going to need to put those in here if you want your Adafruit.io code to work. And of course, if you see other Python examples, they'll have quotes around these. Here in this initialization file, it's reading this INI file as a string already, so don't put quotes in or it actually won't work. So publish max here will determine how often these packets are republished to Adafruit.io. So right now I have this set to 12 because by default I'm publishing to my MQTT broker every 5 seconds. So if I wait for 12 of those to show up, that means I'll be publishing this data to Adafruit.io every 60 seconds. So I don't want to overwhelm Adafruit.io with data. And then of course, if your MQTT broker isn't running on the Raspberry Pi that this script is running on, then you can set it here as well. And this is the MQTT broker that this script will subscribe to. So you want to have it, of course, the same broker as the one you're publishing the data to for it to work. But if you're running everything on this project on the Pi, then you don't have to change those. Okay, well, I'm going to swap in my Adafruit IO key so I can get this to work. And I have those saved here, so I'm just going to copy my initialization files here, and they're the same except for my Adafruit.io key and my Adafruit.io username. Okay, so they're really just about ready to use. So let's do one more thing here. Okay, now that we looked at the initialization files, the last thing we need to do is set up the rc.local file so that this project starts automatically when we boot the Pi. So let's take a look in etc. And let's edit rc.local. Now rc.local is a system file, so we have to use the sudo command. Sudo vi rc.local. Now I already have the commands I need here, but they're commented out, so I want to make sure that they'll work when we reboot the Pi. Now I updated my original commands here to add these extra parameters to make sure that we're running these as the Pi user. I was having problems getting this started from the rc.local script, but I think I figured it out, and as long as I run as the Pi user, we'll have all the Python libraries that we need available to us. So I edited this file to enable these two lines. Of course, I'm using the adafruit.io publishing as well. So if you don't want to use that, you can delete this line or comment it out, this last line here. So anyway, let's quit out of this, right quit, and we have that file saved. Take a look at it just to be sure, rc.local, and we should be able to reboot and bring the Pi back up and see if the project's running. Sudo reboot. Of course, we lost the connection while the Pi is rebooting, so let's give it a minute to come back up. Now we can log back in. And let's see if things are running. So let's go click here, and we'll type in PSAX, and then be able to see if our code is running. And you can see here that the DryOT sensor loop is running, and the DryOT pub to adafruit.io program is running as well. So now our project is installed and working, and we need to see if it works. All right, now that we have everything up and running on the Pi, we need to test it and make sure it works. So let's talk about testing. First thing we're going to do is just use our Mosquito client, command line clients that we've used in previous videos, and just subscribe to the MQTT topics with the command line just to see if it works. So let's bring up my Linux shell and do that real quick. Okay, here I have my Ubuntu shell running on Windows, and I have the Mosquito clients installed, namely Mosquito sub is what we'll be using. So let me try subscribing to some of the MQTT topics that we're publishing on the DryOT Raspberry Pi. Okay, so we need to type in Mosquito sub, then we need to give it a host name or host IP address. In my case, on my local network, my DryOT Raspberry Pi is at 192.168.0.130, and that's the IP address that I SSH to, and I know I can connect to it. Sometimes you can use a name like dryot.local, or raspberrypi.local, depending on if you changed your host name on your Raspberry Pi. But since I'm on Windows and I don't have that zero configuration server set up, I'm just using the IP address. I also need to give it a topic. So my topic is DryOT dryer state, and that'll tell me whether or not the dryer's on or off, and hopefully that'll work. If everything's up and running the way it should be. Yep, there it is. It says on. So I should get that message every 5 seconds because my dryer happens to be on right now. So that seems to be working. So let me try another thing. I'll try looking at light state. And the light in the laundry room is on as well. If I went and turned the light off, it would change to off. Okay, now let's take a look at something like dryer runtime and see how long the dryer's been running. And it might take a few seconds. There, so it's been on for 11 minutes and 8 seconds, and this should update every 5 seconds. Yep, looks good. And let's also take a look at previous dryer runtime. And it was on for just about an hour, so I had run the dryer for an hour before this, so everything looks good. We seem to be getting all the MQTT data that we need. Okay, so let's switch back to the slides here. So we subscribe to MQTT topics using the command line clients, and that seems to work well. Now let's talk about the Android MQTT Dash client. So I'm going to switch to my handheld camera and show you the MQTT Dash client on my phone. Okay, so this is a quick demonstration of the MQTT Dash program on the Android phone. As you can see here, I have a couple of MQTT broker connections set up, and the one I want to use is DryOT, so I tap on that. Then you can see all the feeds that I'm subscribing to, or all the MQTT topics. You can see that it has dryer state on, the dryer runtime, which is currently running, the light is on in the laundry room, and it's giving me the current temperature, which says it's 28 degrees Celsius, but that's really high because, for one, it's the dryer's generating heat, and the EnviroPHAT sensor is right above the Raspberry Pi CPU anyway. So I'm going to have to come up with a way of adjusting that. And then the previous dryer runtime is listed as 0, so as soon as the dryer is finished running, this will go to off, the runtime will go to 0, and the previous runtime will reflect the amount of time that the dryer ran. So essentially, that's how we monitor everything on the Android phone, and we can do that anywhere in the house. Just bring up this app. And again, no custom programming was required on the Android app, just using the program called MQTT Dash. Okay, we're back from the little demo of my Android phone. And so with that, if you're happy with having MQTT Dash on your phone or an equivalent app on your iPhone and the dryer set up, then that's all you need. You don't have to have anything else. But what I did was I went ahead and set up adafruit.io, and I created a bunch of feeds, and I created a dashboard so I could monitor it from anywhere. I could be at work or out, and I could monitor whether the light's on and whether the dryer's on. And this is what it looks like. So over here on the right side, I have my Adafruit IO feeds. I created a group called DryOT, and then I created a number of feeds for that. I have dryer runtime, and it gives me the MQTT equivalent, or the Adafruit IO equivalent, dryer state, light level, light state, previous dryer runtime, and temperature. And then using all these feeds, I set up a dashboard. A free account is allowed to have up to 5 different dashboards, and I believe it's 10 feeds, so I'm using most of my free resources on Adafruit IO for this project. So you can see here, I arranged on the web page, and I created a kind of an icon to show you whether the dryer's on or off. That's why I'm using 0 and 1 for the dryer state and the light state, because if it's 0, I can tell it to display the red icon, and if it's 1, it'll display a green icon to show me whether it's on or off. Then, of course, it's just using text for the dryer runtime and the previous dryer runtime. And then I have a gauge for the temperature and the light level, or lux. And you can see here that the light is off because it's only reading 19. Let me show you the live page real quick. So here's the actual data coming to adafruit.io. You can tell the dryer's on, the light's on, temperature's a little higher. Again, it's not very accurate. And the light's on, so you can see that I'm at 220 lux. So I set my threshold in the settings for 50, so it's well above the threshold for determining that the light's on. It's been running for about 15 minutes, and the previous dryer time was 59 minutes. So we're getting all this nice MQTT data to our Adafruit IO dashboard. And the nice thing about this is we didn't really have to do anything special. I just had a custom Python program that subscribed to the MQTT data and republished it to Adafruit. It doesn't know anything about the EnviroPHAT sensor. Okay, so I could demonstrate a few things here. I am running the dryer. I showed you that, but the light is also on, so I can go downstairs, turn the light off, and then you can watch what happens. So let me switch back to Adafruit here, and I'll go run and do that. Be right back. Okay, I'm back, and you can see that the light's off, and the lux level went down to 17, showing that it is working correctly. I think I'm pretty happy with the way things are working, and I'm just about ready to call this project done. Now, some of the future work I need to do is I need to calibrate the temperature sensor. It really isn't that important to me because the basement stays at a pretty good even temperature, but it would be nice to have it a little more accurate. And then, of course, one of the things I'd like to do is set up a little standalone monitor in the kitchen using an Arduino, like an Adafruit Feather, with the ESP8266 chip, so we can actually monitor it without bringing up a phone or a computer. I think that would be pretty cool. So to wrap things up, I showed you the entire, very simple Internet of Things project using the Raspberry Pi and MQTT. Everything from soldering the header on the Pi and the EnviroPHAT to putting it together, printing out the little 3D holder, testing it out, installing all the Pi software, and getting the project up and running. You're going to want to visit my GitHub repository for this project. It has a very simple summary of how to install everything and how to get it up and running on the Raspberry Pi every time it boots. I do have a link to my videos, Part 1, Project Overview and Assembly, Part 2, the Raspberry Pi software setup, and I'm going to be putting this video on here as well. And of course, all the code is here. So you can take a detailed look at all the Pi code. I didn't really go into detail in the code itself, but it's all here. And you're welcome to check it out and use it and modify it as you need to for other Internet of Things Pi projects. I mean, it wasn't the most exciting project in the world, but really the purpose was not to have the ultimate dryer monitor, but was to try to do something from start to finish with the Raspberry Pi and MQTT. So stay tuned as I try to add some more capabilities to this project, and it might be neat to do something for the future, like put an alarm for the temperature. Let's say the dryer was overheating or something. I might want to get a text message to tell me, hey, there's something wrong with the dryer, you better check it out. And I was also thinking about putting some sort of air quality sensor on the Pi as well. Since the laundry room is where we have our gas furnace and our gas water heater, we might want to keep an eye on that as well. That would be some good data to have. So anyway, that's the project for now. And I'm going to try to continue to make some of these Internet of Things projects with Raspberry Pi and Arduino and some of these neat little gadgets you can buy. Thanks for watching, and I'll talk to you in my next video.